maxima and minima of functions of two variables. Maxima and minima of functions of two variables. What are the conditions for the function to be maximum or minimum? So here let f of x comma y be the given function. So conditions for the function to be maximum or minimum. First, find dou u by dou x, dou u by dou y, dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square. First find the partial derivatives. Dou u by dou x, dou u by dou y, dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square. F of x comma y or u of x comma y. F of x comma y or u of x comma y. Here dou u by dou x, dou u by dou y are first order partial derivatives. Dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square are second order partial derivatives. So notations for these are this is R, this is S, this is T. So R is dou square u by dou x square, S is dou square u by dou x dou y, T is dou square u by dou y square. So these notations we are using in maxima and minima. Now next step to find stationary points for this solve. First order equal to 0. First order means fx equal to 0 and fy equal to 0. That means equate this one, first order. So dou f by dou x equal to 0, equate it to 0, fx equal to 0 and fy equal to 0. By solving this, we get points. So those points are called stationary points. So first step, find partial derivatives of the given function. So dou u by dou x, dou u by dou y, dou square u by dou x square, dou square u by dou x dou y, dou square u by dou y square. Then second step, to find stationary points, first order equal to 0. So solve fx equal to 0 and fy equal to 0. By solving these equations, we will get points. So those points are called stationary points. Then at these stationary points, the function is having either maxima or minima. So at these particular points, we have to check whether the function is having maxima or minima. So what are the conditions for the function to be maxima or minima? Now the conditions for the function to be maximum or minimum. So dou square f by dou x square is what? Dou square f by dou x square, that is f suffix xx, that is r. This is dou square f by dou x dou y, that means s. Dou square f by dou y square, that is fyy, which is t. So using these notations, we are going to write the formula. So conditions for f of x comma y to be maxima or minimum. First condition, rt minus s square greater than 0. rt minus s square greater than 0. rt minus s square greater than 0. rt minus s square greater than 0 means the function is having either maximum or minimum. Rt minus s square, just now we found stationary points. After finding stationary points, we have to substitute those points one by one in RST. After calculating those values, we have to check this condition, rt minus s square. Then rt minus s square greater than 0 means the function is having either maxima or minima. In particular, whether it is maxima or minima. And or less than 0 means f of x comma y is having maximum. Rt minus s square greater than 0 means the function is having either maxima or minima, and or less than 0 means the function is having maximum value. Second condition, if rt minus s square greater than 0 means the function is having either maxima or minima, and or greater than 0 means f of x comma y is having minimum value. Rt minus s square greater than 0 means the function is having either maxima or minima. In particular, or greater than 0 means the function is having minimum value. Next condition, rt minus s square less than 0 means the function is neither maxima nor minimum. Neither maximum nor minimum. So the function is neither maxima nor minima. So these points are at this point, the points are called saddle point. If rt minus s square less than 0 means the function is neither maxima nor minima. So these points are called saddle point. Fourth condition, if rt minus s square equal to 0 means nothing can be said about the function. Further investigation required. No conclusion. Further investigation required. So these are the 4 conditions for the function to be maximum or minimum. So first condition, if rt minus s square greater than 0 means either maxima or minima. If r less than 0, the function is having maximum value. If r greater than 0, the function is having minimum value. Next, if rt minus s square less than 0 means the function is having, that means the function is neither maxima nor minima. So these points are called saddle point. If rt minus s square equal to 0 means no conclusion. Further investigation required. So these are the conditions for the function f of x comma y to be maximum or minimum. Now we will see few examples.